I'm Anil Kumar. I'm going to share a series of videos on vectors, equations of lines in R3. These videos are with a different concept. We're actually going to use more right side of the brain than the left. So while you're working with vectors, my suggestion is that visualize, graph, and then find the solution rather than concentrating on algebraic calculations, right? So that's kind of key to understand all these videos on vectors. I hope that suggestion will really help you to understand and appreciate vectors. Okay, so now the question before us is to how to sketch a line in 3 space. Now that is a very important question, so many times asked by the students. So what I'll do here is kind of sketch the coordinate plane for 3 space, right? So visualize as if this is the wall in front of you and that's the side. So this is the room in which you are sitting. So that is your space, right? So this is 3 space and always will go like X, Y, and Z. So this is our X-axis, Y and Z-axis, right? And of course that's the origin. Okay. Now in this video we will also understand how to make an equation of a line and then how to sketch. To define the line, what do we need? We need a point, right? So, and slope. Now we need a point and I said slope, right? Well, I'll correct that part also. So let's take a point. Let's say we call this point as P and 3 dimensions. So let me write some value along the X, which is, let us say 1, and we take 2 here, and then we'll go up and let's take this as 3. Okay. So let us say this is the point. And what did I say? The second? Slope. Slope actually is rise over run. If I'm having 3 axes, then rise means what? Oh, that's confusing, right? So slope is not the term which we are going to use now. What we are going to use is the direction vector. Okay, so let me write the full word, direction vector. So from this point, in which direction the line is moving, it makes sense. So instead of M, I'm going to write D now. Okay, D. Okay. So direction vector, let's take one where let's take some negative values. So minus X, let's say minus 1. And along the Y, let's go right 1 unit. And along this axis, let's go 2 units. Okay, that's fine. So let that be the direction. So we have a direction vector and a point. If you are given direction and point, can you write down the equation of a line? Simple. Equation of the line will be written as, so we are looking for X, Y, and Z coordinates, right? Every point on the line has a coordinate point, and that is linked with the first point, which we have taken 1, 2, 3 plus parameter T, right? Set of points in this direction, right? So when they are in this direction, we just say scalar multiple. So this T is the scalar multiple of the direction. Does it make sense to you, right? So simple as that. Where T belongs to set of real numbers. Done. So that is how you get equation, and this equation is the vector equation, right? Since you did R2, so you understand most of those terms. So I'll not repeat those, okay. So that's the direction vector. So stop calling or recalling slope, right? Now let's concentrate on direction vector. Okay. Now I could have written this equation in a different form also. What are the other forms? The one form is we could write parametric form. We could write X equals to 1 minus T, right? Y equals to 2 plus T, okay, and Z equals to 3, 2 times 2 plus 2T. We could do this. That is one form, right? Another form is the symmetric form. Symmetric form, let me write that also. So X minus 1 over the direction, which is minus 1, equals to y minus 2 over, this is 1, okay, and that is equals to z minus 3 over this 2, right? So that is the symmetric form, right? So we got equation in all three forms. Remember, we do not have Cartesian or scalar form of equation in a plane. Oh, sorry, in R3, since that form represents a plane, okay? So we do not have scalar or Cartesian form of the equation since that represents a plane, right? So just to say, this is the vector equation, okay? Okay, and this one, this set is parametric equation, right? Let me write it. Equation of line, and this one we call this a symmetric equation, right? Okay, I don't know, I'll use this space for something else, so I'm just squeezing in here. Okay, these are the only three forms of equations which you'll be dealing with, and let me write down a note. No, underline, okay, Cartesian or scalar equation in R3, okay, since that represents, that will represent actually set of points, and that is a plane, right? That will represent a plane. So we'll talk about it later, but it's kind of good to know at this stage. Okay, now let's get back to the main problem, which is to sketch a line. Anyway, so we know how to get the equation of a line. Now we'll see how to sketch a line. Okay, so let me get some good pencils now. Okay, so we need to first locate the point 1, 2, 3 in this R3, this space. Now 1, 2, 3 means 1 is along the x-axis. So let's say this is my 1. Okay, so this is my 1. Let's say this is my scale along the x-axis. Okay, so we'll move 1 unit in this direction. So we get to this point. This is 1. 2 is along the y direction. Okay, so 1, 2, and 3. So we'll move this 1, 2, and 3. Do you see this point? So this point is, this is 1, 0, 0. We didn't move along x, y, and z. As we come here, it becomes 1, 2, and 0. And to get 3, we'll move upwards 3 units. Okay, so this is 3 units, right? So we'll move kind of 1. I mean, we are going from here, so 2 and 3. Okay, so we come to this place. So that point is the point P for us. So I'm going to join O with P. But I hope you understood how I got this point P, right? So that's my point P, right? So I'll call this as point P, which is 1, 2, 3. Good job. So we got a point. Now we have to figure out this direction. Direction is also kind of same thing, just as we did here. -1. So -1, see, this is your XYZ. Think like this. This is your XYZ here, okay? So from here, -1, this is plus side. So that is negative side. So from here, -1 means 1 unit to inside. That is minus x in the direction -1. 1 positive this side, okay? And 2 up. So we'll go 2 up. So 1 up, 2 up. So you come here. So you come here this side, okay? So that is your second point, right? So this is your second point. If I join these 2 points, I will get my line. Do you get an idea how I got this line? So what I'll do here is I'll just join these points, right? So, okay, so this is my line which represents all these equations, right? All these equations. I hope it is simple. It's not that difficult. So the idea is first locate the point. So we'll call this as the vector R0, okay? So this is R0, right? And then any other vector. So this is the second vector which we found. We just multiplied, we used t as 1. You could have used -1 also to get more points. Okay, so we get the second vector, so which is kind of, let me join this. Okay, so this is, let me call this as R, right? And let me call this point as Q. So PQ is this part of the segment between these 2 points. Is it okay? PQ is this vector represented by these 2 points. And once you extend both directions, you get your lines, because line always extends in all the directions, right? I mean both the directions. And it has infinite points. Infinite points is taken care by t, since t will have infinite values. Corresponding to each value will have different points. Okay, so I hope you've learned how to write equation of a line in R3 and also how to sketch. Now let me elaborate on one more part. That is, I say t is like giving all points on the line. So if t is equals to -2, in that case what is going to be x? Let's calculate. Okay, I'm just extending this. If you want, you can close the video and move on to the next one. Okay, so if I write t equals to -2, then x will be equal to what? X will be equals to 1, 1 minus -2, that is equals to 1 plus 2, which is 3. Y will be equals to 2, minus 2 will be 0, and z will be equals to 3 times plus 2 times -2, which is -1. So at t equals to -2, we'll get a point which I'm writing like this, since this is a vector, right? So x value is 3. We'll call this as a position vector, 3, 0, -1, right? So this is the third point. We call this as a position vector. Why? All these vectors which I've shown, they originate from origin, right? So they are position vectors. Perfect. Vectors could be plotted anywhere, as you can see. They are all equal. If I write a line, if I draw a line with same length and direction anywhere, both those vectors will be exactly same. But if I position it so that the starting tail is at the origin, then we call them as position vectors. Position vectors are unique, right? So that is important to understand, position vectors. So when I say R0 and R, these are position vectors, okay. We could say OP and OQ as our position vectors for the points taken, right? So this is very important to understand. Okay, anyway, so what you will find is that if I extend this line, this point 3, 0, -1 will lie on this line with t equals to -2, right? So sometimes we can do reverse calculation also, right? Anyway, I'm Anil Kumar, and I hope that helps. I'll take one more example to just repeat the same thing so that you all get it, and ensuring excellent marks for all my students. You can always share and subscribe my videos. Thank you and all the best.